next thing we're going to look at is we just did all this parsing of files and templates. We're going to look at creating servers. So when you do like old school web programming, and this is where Go really starts to shine. Okay, a couple things about how Go shines. One is like your servers that you're going to create are natively just built in going to be concurrent. And so when a request comes in, it's going to get launched in the background under the hood. I was going to say under the covers, but it's a slightly different metaphor. Under the hood, the internals are that every request becomes its own Go routine, which means it's running concurrently, and you don't have to manage that, right? That's just the standard library and the different packages or the different functions I'm going to show you how to use. So that's one of the things, right? It handles a whole bunch of requests. Another one of the things is that your server, you are building the server and you're building the web programming. You're doing the server and the server-side programming, and that gets all bundled into one chunk of binary. Okay, and so that binary is going to run really fast because those two things are all part of the same program. They're not two separate programs having to interface with each other. Old school programming, you do PHP and run it on what? LAMP, Apache, right? Linux, Apache, MySQL, PHP, right? If you do like Python or even Node, you got to like bundle that with stuff and make sure that certain things are installed on the server and okay, now it could run, right? With Go, you are building your server in Go, you're doing your server-side programming in Go, you're compiling that all to binary. That is running as a standalone executable program on whatever machine you put it on. You could go get a virtual machine, Linux, up in the cloud, right, running Ubuntu, and put your binary on that and then configure it just to make sure your ports or whatever in the DNS and all that stuff straight. And it'll just run from those zeros and ones, and so it's really fast.
You don't even have to have Go installed.
You don't even have to have Go installed, right?
Yeah.
It's just like here's the binary, run it. It's a program, and so you're creating a program that does that. Now that's really complicated, or that's sort of kind of complicated to stand up your own machine and and then like configure your machine, your Ubuntu, and then make sure that your whatever they are, C records, A records, DNS, all that stuff's configured correctly. And then, okay, I want to be able to use a CDN, and I also need to account for like, HTTPS and make sure I have certificate authorities signing my certificates so that, I could serve securely when people log in, right? That's pretty complicated. And we're going to use App Engine, which is platform as a service. And so we will just concentrate on writing our Go code and writing our web app, and then we'll upload that to Google, and they'll take care of all of our infrastructure for us, right? They'll take care of all the hardware, all the software, and all the distributions, and the C records and DNS and all that stuff, right? So all we have to do is kind of like concentrate on writing our application, and they'll also allow us to scale really easily, and you pay a little bit more for that. But it's a lot less than if you hired somebody to be your full-time DevOps engineer, to manage all that hardware. So that was my best to sort of mimic what Caleb said. I don't know how well I did. I didn't really understand any of what I just said. I just memorized that from what Caleb told us. I understood a little bit, but Caleb talks about all this. If you go and you listen to the Summer Web Bootcamp videos, this is day 10 in the morning, the hour-long video. I was just watching it before I came in here. He talks about all that. But before we get to using App Engine, which is going to be down here, like, well, it's not even on here, but it's going to be right here, App Engine, right? We're going to kind of come back up here after we go through all these files. But before we get to App Engine, I just kind of want to show you how do you build up a server, how does a server work, and get you familiar with that stuff. And then eventually we're just going to go to App Engine, and all that server stuff will pretty much be taken care of for us. Okay, so this is kind of fun too, but here we're going to create a TCP server, and if you look at how, if you look at network layers, internet network layers, I like the way that one looks. Okay, so we have physical data network transport session presentation application. I don't totally understand all this stuff. I never studied computer science. Somehow I ended up in a field where they're asking me to teach this stuff, and I find it kind of interesting, so I said yes. But, you can see that they kind of have a separation of concerns here. right, where they've assigned certain responsibilities to certain, abstractions, right? This is where the physical layer is going to be. So I imagine that's like the cables, And if you look at the OSI, Network OSI, which stands for like something, Open Source Interconnect or something, I have no idea. What does OSI stand for? There we go. So that's like, it talks about these layers and networks also. And if you have anything you want to add in here to help educate me, fantastic, right?
I'm Network Pro certified. It's like a spin-off to Network Plus, but it's also focused on Windows.
Oh, yeah?
I'm pretty good at breaking down the OSI model. Like the bottom 3 layers, the physical data link and network.
Come up here, dude, so we get your voice on the video.
You really want? No, I'm scared of that. I'm not going on YouTube.
Okay, say it from back there.
You want me to say it?
Yeah.
Well, yeah, so the physical data link and network layers, they directly correspond to the 3 networking devices, which is a hub, a switch, and a router. Because a hub uses bits and bytes and it forwards everything to all the devices that it's plugged into. A switch uses MAC addresses because it uses frames at layer 2 at the data link layer. And then a router at layer 3 uses a network layer. And then so that's like the first 3 devices there. I think that's a cool pattern to use if you're going for the certification. Then you keep those in your head, and then it really helps you get the fundamentals and not be confused as much.
Cool. Yeah, and so like if we translate this to the internet as a network, right? The transport layer is where TCP is, my understanding, and the session layer is where HTTP is. Okay, and so HTTP is on top of TCP. And if you look at what's TCP stand for, Transmission Control Protocol. Cool. Transmission, transport. What's HTTP stand for? Hypertext Transfer Protocol. Well, there's transfer in that word too. Is there something about sessions? We talk about sessions, so maybe that's maybe that's a miss thing. But anyhow, we got those 2 layers, and let's see if there's another one that kind of says more HTTP, TCP. Session transport, same thing. I'm looking for like just something that shows me. So here's transport layer, TCP, right? Transport layer. Internet layer, that's IP. Network layer interface, Ethernet, that's kind of cool. And then I'm looking for HTTP on top of this, but I don't see that up there, TCP. So that's the way Caleb talked about it. I'm just going to like reference the Bible of Caleb. Internet protocol, TCP application. I'm just looking for HTTP being on top of
HTTP is the
TCP.
application layer,
I'm not sure if
I
think so.
Compress it down to the application layer at the top to the physical layer.
There we go.
Is all just the APIs in your browser, or the APIs that the programs are calling are in the application layer. And the physical layer is the core. So it makes it from your program all the way out of the computer.
This is a pretty good one right here. Network access layer, internet protocol layer, right? IP, and then TCP IP transport, and then on top the application layer, HTTP. So I have no idea if these are accurate. Like I said, I've never cited this, but I'm going to assume that they are because they're on the internet. They must be correct, right? I'm also sure I just violated all kinds of intellectual property. Here's a picture. I'm going to incorporate that into my teaching. But hopefully that falls under fair use. In academics, you have some leeway to just use stuff. Yeah, so TCP server, this is all we do. We say, hey, there's this net, right? So we look at godocs, godoc.org, and we look at net HTTP package, right? There's a net HTTP package. I wonder if there's just a net package. Well, I got that again. So package net, okay? And then we have here, we're just importing package net, and we have net listen. So what does net listen do? Listen. Listener. Here we have listen. It gives us a listener and an error. A listener is an interface that has accept, close, and address. Cool. And to get a listener, right, we do listen, and that gives us a listener and an error. So we're doing listen, and that gives us a listener and an error, and we're listening on TCP 9000, and listen wants the net, which is just like, what type. Could be TCP, TCP4, TCP6, Unix packet. And then we have a listening address, which is a string, which ours is 9000. So we get a listener, And a listener has accept and close. Well, close is there. That means we must close it. So we need to close it since we're opening it. So we have defer close to close our listener. And then we also have accept. And when we accept a listener, we get a connection and an error. So we check the error to see if there's a problem. Right? We get a connection and an error when we accept that. And we're also doing this inside an eternally running loop to always be listening. Right? Is there anything coming in? And then a connection, when we get our connection, right? A connection is a interface type, and it has the read and the write interfaces, right? The read interface, the write interface. And then it also has a close, so we better close it. Do we close our connection? We do our connection close right down here, and it's a reader and a writer. So we could read from our connection, and we could write to our connection. And you know what this is going to do right here? This is just going to echo. So we're listening on our connection. We could start our server. Somebody could connect to our server and send us a message, right? We're listening for that message right here because IO copy takes a writer and a reader, and a connection is both a writer and a reader. We can see it's a reader and a writer, right? And so we're going to, which one is which? Writer, reader. We're going to read, right? We're going to read from our incoming connection and then write back out to our connection. So we're going to send back to the client whatever the client sent to us. So let's see that in action. So we're going to change documents and go into 99.14. Go run main. And then here, and I put these notes right here, telnet localhost 9000. So you go to a different window, right? And that could be anywhere. And I'm just going to do telnet localhost 9000. So I just connect to the server, say hello to the server, and the server says, reads that, and then it copies it right back. Reads and copies right back. Reads from IO reader and copies back to IO writer interface. Whoa. So there's our TCP server. All right, well, whatever, kind of interesting. Here it is again. And this time, same stuff down here. But instead I put, a created function handle, which I'm passing in my connection. So that function here, handle, which I wrote, it's not a special function, it accepts a net, from package net, a type connection, right? And I'm going to defer the close of that connection. And now I'm going to use scanner. So scanner is kind of a cool thing. And if you're new to it, I put in comments here to sort of let you know what's happening. So whatever you're doing now, turn to the overhead projector and focus on this so I could explain scanner to you so you understand scanner. So new scanner returns a new scanner to read from R. The split function defaults to scan line. So R, you're asking yourself, what's R? These are the comments from the official documentation. New scanner returns a new scanner to read from R from a reader. And the split function defaults to scan lines. Not sure what that means yet, but let's see. Right? So here we know that connection implements the reader interface. So new scanner reads from a reader, and we're giving it the reader of the connection. So it's going to read from whatever's coming in on the connection, and it splits. The split defaults to scan lines. Right? So it's going to read everything that comes in. If I gave it a whole page of text, it's going to split those on the line. Right? So on line returns. So it's splitting it on line returns. And then scanner scan for scanner scan is going to loop through each of those lines. Right? So now I've got my scanner, and now I'm going to scan all that data I have, and I'm just going to go through it all line by line. So it's already split it out by lines, so that's how a scanner works. I know it's like a little bit of like, oh, it's doing a lot under the covers. It's doing a lot under the hood internally. And you could go look at that in the source documentation if you want. I have not, right? But that's what it does. It, listens, splits it by lines by default, and then you can loop through each line. So scan advances scanner to the next token or line. You could also say line which will then be available through the bytes or text method, right? So then I'm looping through each line, and then I say scanner text, and that gives me the line. So text returns the most recent token generated by a call to scan as newly allocated string to holding its bytes. So it returns the most recent token generated by the call to scan as a newly allocated string holding its bytes. So it's a string is made up of slice of bytes. So scanner text gives me a line. I could print that line. I'm kind of also interested in printing the type. What do you think we'll get? String or slice of bytes? Right, just curious. And we'll put type. And then we're going to format sprint, right, from server. So we're just adding from server to the beginning of that string. And adding that to the variable ln, right? And then we're going to write that with fprint, because file print, if we look at file print, writes to a writer. File print writes to a writer. And so that writer, our connection implements the writer interface, so we're going to fprint to the connection that text. And so this is called an echo server. Pretty similar to the other one, but just implemented differently. Telnet, localhost. Hello. From server, hello. All right, and if I look at what it logged over here, my type is a string. More info. More info. Type is a string. I think I misspelled that. I put type P. There we go. So just another way to do it using scanner. Now, why did you see scanner? Because you come across that. So now we could do a Redis clone using this. So Redis is an in-memory database. It's an open source in-memory data structure store used as a database cache and message broker. So how do we create Redis? Same thing. Net.listen TCP 9000. And then accept our connection, then pass our connection to our handle function, which we are writing to handle that. And then, we're going to defer, close our connection. And then, buff.io new scanner, read our connection with a buff.io new scanner. And that will break it out by lines. And then we're going to loop over every line. Right? Loop over every line. I think that's where that ends. And then we're going to get each line of text. And then we're going to take each line of text, and it's a string. We're going to say break it up by fields. And strings.fields. Splits the string S around each instance of one or more consecutive whitespace characters. So it takes a string and gives us back a slice of strings. Basically, it breaks it up into the words. So each field in the word. So we got each of the words. Okay. So somebody connected with Telnet, and they typed something to us. The server received that. We read it with new scanner, got our scanner, and then we're looping over every line, and we're getting each line with that scanner text, and then we're saying take that line and break it up into words. And then if the length of the words is less than 1, just start over. They didn't give us anything, right? So less than 1 would be 0, right? There's nothing there. And so maybe that'd be clearer if I just did length is equal to 0, right? I think that's clear. And then we're going to switch on FS0. So that's the zero-base index, right? We're accessing the binding index. It's a slice of strings. That's what we get back when we split strings fields. We get a slice of strings. We saw that in the documentation. Just a reminder right here. Get a slice of strings back. So we're using an index access to get the, since it's zero-base index, the very first character. So the first character, if it's get, we do this code. There's nothing there yet. If it's set, we do this code. If it's del, we do this code. There's nothing there yet. And the default is, if it's none of those, here's how you use this. You use get, set, or delete, and then you give me a key and an optional value, right? And then we're just going to write back to our connection whatever the line is, right? Well, that's the line in this case. And I use format print line, fprint, and I also use write string, just to illustrate that since they both write to a writer, you could use either. So that's redundant, but I just wanted you to see, hey, you could use either of those to write back. How many people are feeling like you're in the weeds a little bit?
Is it a bad thing to be in the weeds, or is that a good thing?
I think he means confused.
Yeah.
Or overwhelmed a bit.
Okay.
Yeah, a little overwhelmed, a little confused. You know, it takes a while to wrap your head around this stuff. Carson's just ready for Miller time. He's
I
like,
have to go get a jacket before I go see Monica.
All right, so check it out. Here's the next step. So now we want to do something with our get, our set, our delete. So I've added code to do something. And I've made a map. A map is a key value pair. Okay? So map, string, string, right? Making it. And I'm assigning it to the variable data. And so map, if you're like, oh, what is a map? You could always go by example. You can say, well, how are maps and how do they work? You can see, okay, here's a map. And then I could store something at this key. I could store this value. At this key, I could store this value. I could print that, print my map out, and I get this. It's a map with those keys and those values. And I could say, hey, value 1 is equal to whatever the value is in the map stored at K1, and I could print that, right? So that's going to be 7. I got 7 right here, assigned it to V1, and then printing out 7 right there, so I should get 7. Right, okay, cool. Reminding myself how maps work. And then I come back here, so I make my map, and what's going on, right? Well, if fs0, my first word, which will be either get, set, or delete, because that's the usage. If my first word is get, then my key is going to be my second word, which will be at index position 1, zero-base index, the second word's at position 1, right? I know it's kind of weird. And there's my key, fs1, right, on line 39. And then my value is going to be, because I'm getting, right, my value is going to be whatever in my map is at data key. You know, they pass me a word, and I'm going to look that word up and get that value. That's my value. And I'm going to write that back. I'm going to write my value back using fprintf. So it puts that value right there and gives me a new line and connection. It might have been more clear if I did fprint line and just did this. Could have done it that way too. Maybe that's a little bit more clear, right? But just kind of mixing it up so you see, you know, the different ways to do stuff. Got to take that back to fprintf for formatting verbs. Set, right? So if my length of my words, so I broke up my words, and that's how I got fs. Right here, I said string fields, give me my fields. If that length is not equal to 3, then they didn't use this correctly. Because with set, they're going to say set, key, value. So I need that to be equal to 3, right? And so if that's not true, I could say, hey, expected value. And maybe I should have printed that usage thing and then I get my key, I get my value, and I say in my map at this key it's equal to this value. And then delete works similarly, deletes it. So let's see that in action because it's pretty awesome.
So why do you only have the if length on that set instead of somewhere above where you're checking that condition?
Right here?
On the
Because
set.
it could be just 2 right here, and you'll see
But
that.
all of them are 3.
No, get could just be 2. Get key. I'm not putting the value on get.
Okay.
Delete key, right? Delete key. Yeah, no problem. I don't have the answer, actually. I just am reading from a script. Sorry. That's a joke. Some answers I do have. Gladly, I could say no. All right, so I just ran that, and now I'm going to do telnet localhost 9000, and I'm going to say set fave chocolate. Nothing happened, but get fave returns chocolate. Set Kai hand on mouth. Get Kai hand on mouth. Get Rio. Nothing. Set Rio. That's cool. That was actually Kai, but get Rio. Del fave. Get fave. Nothing there anymore. So that's a Redis clone, just a basic one. And last thing I'll show you is just for fun, and then you can look at this code. And so I'll just run it. And what'd that just do? How many letters is N away from A? 13. How many letters is N away from A away from N? 13. So it's a rotate 13. So it takes each character and rotates it 13. It does a little basic encryption. Oh, I spelled that wrong. So it's rotate 13. It went into symbols. It doesn't work with numbers. Huh? No, that's right here. So that's the rotate.
It would only do it with the letters of the alphabet.
I wrote it, so
Oh.
yeah. So it's so you guys have a lot to play with between now and Thursday. I want you to recreate Redis. So even if you just go in and copy my code, just retype it. All right, but retype it and make sure you understand the parts. And when you get to something and you're like, I don't quite understand what, let's look at the slightly less convoluted one. I don't understand what string fields does. Go look at that. Or what is the writer interface again? So an interface is anything that implements a method set. And then pretty soon we'll get to App Engine where they do all the server stuff for us. How do you guys feel? Awesome today?
Yeah.
Good. So even though it was a little bit challenging, it's like you're excited? Good, yeah. It's like, okay, I can start to see I'm going to be able to do some pretty neat stuff. And Kai, I think you'll be glad to hear, man. You're going to be able to employ this to do some really powerful concurrent parallel hacking. Yeah, very soon.
Wow. Never thought I'd learn anything like that at school. Well, it looks cool either way. This is really cool stuff.
Bye, Rio.
It'd be fun to practice it.
All right.